we're already in that form, log equals number, okay? So what I want to do is I'm going to start with the middle one, the one I said was the easy one. So if I have 6 plus 2 times the natural log of x equals 8. Maybe we should have done the third one. Oh, we'll do this one. If I'm going to get this in log equals number form, then I'm going to have to solve for that log. I'm going to have to get that log by itself through the usual means, right? So at the moment over here, it's not just the natural log of x, it's plus 6 and times 2. And if I'm solving and getting rid of those guys, then the first thing I usually get rid of is adding, right? So how do I get rid of adding 6? I subtract it off. So 2 times the natural log of x equals 2. So far, so good. Now, there's 2 ways to get rid of this 2. One of them, I think, is decidedly better than the other. Okay? What I would recommend doing, don't worry, it's just a spaceship. What I would recommend doing is dividing this guy off. Okay? The other thing you could do is you could bring this guy up as an exponent, right? If I have a coefficient, whatever, but then, when you do that, then you have the natural log of x squared, and you're going to have to solve a quadratic in that case. But me, if I just divide it off, I don't have a quadratic equation that I'm going to need to solve. It's just the natural log of x equals 1. So by solving for my log, does this now say verbatim, the log of something equals a number? Okay, so at this point, we rewrite in exponential form, okay? Always start with your base. What's my base on here? If you see ln, that's our natural log, that's log base e. What does it look like if it's log base 10? Yeah, it looks like this log. This is going to be log base 10. Don't forget that in about 5 minutes. Okay. This is log base e, natural log. So my base is e. Which one's my exponent? Equals. Okay, there you go. So if x equals e to the first, then x equals e. And I need to check it. It's going to check, but that's my solution. If I plug it in, 6 plus 2 times the natural log of e, does that equal 8? Okay, well, let's work sort of inside out. Does anyone remember what the natural log of e is? What happens when I take... That's not what the natural log of e is. E is 2.71828, whatever. But if I take the natural log of that number, this is log base e of e. Isn't this 1? The natural log of e is 1, and 1 times 2 is 2, and 2 plus 6 is... So it checks. And it was going to check as long as I wasn't trying to take the natural log of a negative number or something like that. Okay. Next up, I want to do the third one down there. The log base 2 problem. Now working this problem is going to be a little bit different because it's not just one log that we have to isolate. We've got a couple of logs, but we can use a very similar trick. We can condense those 2 logs as a single log, right? But this time when I condense them, how do I do it? I'm going to have to divide their insides, their internals, if you will, their arguments. So this is the single log base 2 of what on top? X minus 3 over x on bottom, and this equals 2. Okay, so by condensing, I was able to say the log of something equals a number again, right? So we go to exponential form. What's my base? This is log base 2. What's my exponent? It's also 2, but it's a different 2, right? This is my base, this was my exponent. So 2 squared equals,
X minus 3.
yeah, the inside stuff. You know what is 2 squared? Let's go ahead and change that. Let's go ahead and just call that 4. Alright, so how do you solve something like that? Yeah, multiply the x off. This is a rational equation, you clear fractions. The multiplying by x cancels the dividing by x. So 4x equals x minus 3. Is that negative 1? Am I getting x equals negative 1? But we check it. Right? See immediately what happens. That's log base 2 of negative 4. I can't do that. So x cannot equal negative 1. And I've got, once again, no solution.
You're getting that a lot. So we get that a lot.
It happens.
Solution a lot.
I mean, not like 75% of the time a lot, but...
Well, like on the last test, it was like a lot of, you know, and the following solution.
Yeah. So what's next? This one? Yeah. Example 6, the last log equation. So the log of x equals 1 minus the log of x minus 6. Remember, we're calling this one log equals number because of that free-floating 1. I'm not able to really sneak that 1 inside of a log so that I can make this a log equals log problem. Okay? So what we're going to do, the trick we said was, why don't we put our logs together on the same side and our regular old numbers on their own side. So I'm going to add this guy over. This is the log of x plus the log of x minus 6 equals 1. Okay? And so then, one more time, I can condense those guys down as a single log by multiplying the insides. So this is the log of
X squared minus 6.
Oh, wait a second, because I want to make sure we all agree on the next step. Right now we have log equals number. Yes? And when it's log equals number, you go exponential form, starting with your base. What is my base? My unwritten base is base 10. So this is 10 raised to what power? Yeah, my 1 is my exponent equals the x squared minus the 6x.
So it's only when it's a log equals log do you go to the other quadratic?
What?
Because being that it was x squared, you don't, because the log is still there? Because you canceled the logs in the other one?
Okay. Now let's clean up real fast. What is 10 to the first power? Okay. We have a quadratic equation. We have to get it in standard form. So I subtract off my 10. And we pray to the math gods that that factors. But the math gods reject our sacrifice. And it doesn't factor. So what do you do when it doesn't factor? You have choices. What? Quadratic formula. That's probably most people's default when something doesn't factor. Now, could you do completing the square? I would say that if you were ever going to do completing the square, this is a good time to do it. Okay, but is there anyone that wants to do completing the square, or do you all want to do quadratic formula? What does yes mean? Does yes mean quadratic formula? Okay. I just wanted to be sure. I was really hoping we were going to do completing the square because it's